Now you say to yourself, where do I see this kind of stuff? So let's go back to our class. And you might have seen a constructor that looks something of the sort like this. I don't know if you guys saw the double opposite. This is a copy constructor. This is a move constructor. The first one, now, when the compiler sees a call that requires a copy constructor, it asks itself, is the value being passed a L value or an R value? If it's an L value, then I'm going to call the regular copy constructor. And what this will do is create a new data segment, a new data memory, a new heap memory, copy the things into it, and do it in the normal way that we've seen. But if what's being passed in is an R value, then this is the function that gets called the move constructor, right? Not the copy constructor, but the move constructor. That's what it's called. And what it would do, it wouldn't create a new value. What it would just do is just take your value and give it to me, right? I would take the right-hand side's data and give it to PTR. That's what I would do. No creating new, no anything else, just transfer of ownership. That's all it does. Now, the same thing is true for the operator equals. Notice that the operator equals works the same way. The assignment is called move assignment. The idea is that if what's on the right-hand side is a, let's just say, for example, we have A is equal to B. So what happens is that it calls the operator assignment. Now, this right here is equal to the C, to the copy constructor. And what it would do, it would copy B to a new guy. The new guy is a temporary guy, right? That's what happens. It's a temp, and therefore it would call the move constructor. And within the operator equals, all you have to do is just steal the memory of the right-hand side. It would always be an R value. If you called A is equal to B plus C, then it's an R value by definition. But even if you call this guy right here, he says, oh, this is an L value, and therefore I can't use the system. Well, that's not really true. You're using the exact same system. Let me just write it bigger. It would be something like operator plus that gets a DC right-hand side. Let's discuss this guy, this right-hand side guy. Well, this is a B. It's an R, it's an L value. This is a call to the copy constructor. The copy constructor is actually creating an R value as a copy of the BL value. So by definition, every time this right-hand side guy right here would always be an R value. And since it will be an R value, then the implementation of the operator, of the equals operator, would just be steal the memory. That's all it has to do. You don't have to go and you know, I mean, you got to nullify what you had before. I'm not saying that. You are equal to something, so you have to nullify that. But you don't have to create a new memory. You don't have to do that, which is what we did in our sophomore year when we took the advanced programming in C++. What we actually did is the implementation of the operator equals, the assignment operator, was very similar to the copy constructor with the exception that the assignment operator checked to see if it's not self-assignment. And if you had some value, then you discarded it and created a new value. But besides that, it was doing the same thing. It was creating a new memory and copying things into it. There's no point. Since once we have our move constructor, then we can actually have over here what's called a move assignment. The move assignment. You don't have to do anything besides steal the other guy's memory or transfer the ownership of the other guy's memory to yourself. Because no matter what happens, always the value that actually gets inserted into the operator equals is an R value, either because it is or because the CTOR made it. So in either way, we're getting an R value, not an L value, and we are able to transfer the ownership. This is what's known as move semantics, which is something that actually developed out of the idea behind smart pointers, which is something which came to solve the problems that we're talking about. So notice how languages develop. New concepts come up, new ideas get developed. And by doing all of that, we are actually getting languages to become much better and much more efficient. The benefit of the technique is obviously very obvious. We save a constructor call and a destructor call every time that we actually do an assignment, or that we do parameter passing of objects, and we have temporaries behind the scenes. All this gets, in a sense, discarded, and we can just do it once and steal the memory or transfer. Let's call it, let's say the correct way. You transfer the ownership of somebody else's memory to yourself. We don't call it stealing, we call it transfer of ownership. And what you're actually doing is you are saving yourself a lot of runtime, which is actually very efficient.